So we're going to look at lesson 1.3 and we're going to look at properties of parent functions. So there are different kinds of functions and the basic function or for every type of function is called a parent function, and every function belongs to a certain family of functions. So every function can be called as a member of each family of functions. So what we're going to look at today is the parent functions. What are the most basic parent functions? And then, of course, we can study further about what are the other members of each of those families. All right, so you have a bunch of graphs here. You can see these are all linear relations. F of x equals x, g of x equals 2x minus 1, h of x equals negative x plus 5. You're very familiar with these three types of functions. They're all linear. You know right away when you see that function what it represents. So if you say f of x equals x is the parent function of a linear relation or a linear function, its slope is 1 and the y-intercept is 0, so you can see it passes through the origin. And then the other two, the g of x and the h of x, are members of that parent family of functions. So g of x here is 2x minus 1, so it has a positive slope and a y-intercept of negative 1. H of x has a negative slope, negative 1, and a y-intercept of positive 6. All right? Now, there's other functions too other than just linear functions. You have also seen the quadratic function. So that's the basic quadratic function, which is f of x equals x squared. But you also have variations of it, like this purple one here, which is h of x equals 2x squared minus 3x minus 6. And then this red one here, which is also a different function, another variation. So these two functions are members of the parent family of functions, which is f of x equals x squared. And here, g of x and h of x are members of the parent family of functions, which is represented by f of x equals x. Before we move on to functions, we need to also understand the meaning of certain terms. One is an asymptote. So this is an example of a function where you can see here that it's in two quadrants, in the second quadrant and kind of in a bit of the three quadrants on this part of this function, right? You will see that this function is approaching an imaginary line, which is this dotted red line. That dotted line, which this function is approaching as the x value increases, is called the asymptote. Okay, so it's a line that the graph of a relation or a function gets closer and closer to, but never meets it at any point. Okay, so it never meets, but it's just like, looks like actually if you extended this, they would actually meet, but in reality, they never do. They're always just approaching. So those are what are asymptotes. They're just, a line that functions or graphs tend to look like they're trying to approach, but they never meet them. Okay. And just before I move on, they have equations. So if you look at this asymptote here, this vertical one, it's passing through negative 1. So its equation is x equals negative 1. And this horizontal asymptote is passing through y equals 2. So the equation of this horizontal line is y equals 2. So you have to be familiar with how to write the equations of asymptotes for different functions, okay? So these are the types of functions we're going to look at. Linear, which we already saw, f of x equals x, and quadratic also, which we just saw, which is f of x equals x squared. We're going to look at three more, which is the square root function, f of x equals square root of x, the reciprocal function, f of x equals 1 over x, and the absolute value function, which is f of x equals the absolute value of x. So let's look at it from the beginning. We look at the linear function. The parent function is f of x equals x. What are the properties of it? It's always a straight line. In this case, it passes through the origin. It divides the xy plane in half diagonally, and it only goes through quadrant 1 and 3. So the way the quadrants are numbered, this is the first quadrant, second, third, and fourth. And f of x equals x, it only passes through 1 and 3. Okay, what is the domain and range for this particular function? Well, the domain is x can be any real number, so x belongs to real numbers. Again, y can be any number on the number line, right? So it has all values from negative infinity to positive infinity on this line. So y is also belongs to the real number group. So y is also a real number. Next, we're going to look at the quadratic function, f of x equals x squared. The properties are, it's a parabola that opens up, as you can see here. It opens up. The vertex is at the origin, so that's the vertex, 0, 0. The y has a minimum value of 0, so you can see that this is the lowest the y value would go, and every other point on this parabola, the y value will be greater than 0. The axis of symmetry, that's the line that passes through the center and divides the parabola into two equal halves. That's this line here. For this is the y-axis, and the equation of the y-axis is x equals 0. And the graph only passes through quadrants 1 and 2. It does not have any part of it in quadrants 3 or 4. So what is the domain and range for this? Well, the domain you can have any value of x from negative infinity to positive infinity on this graph. So x can be any real number, so x belongs to the family of real numbers. And what is the range? Well, y also can be any real number, but it has a constraint, because if you look here, the minimum value of y is 0. You won't find a y value on this graph lower than that. So there is a restriction there. Y is only going to be greater than or equal to 0. So that is the range for f of x equals x squared. The third kind of function we're going to look at is the square root function. F of x equals square root of x. It looks like this. It looks like, like a parabola, but like, inverted, and only one half of it is there. So it's kind of like this. This is f of x equals square root of x. And if you see the way it's written here, you can write f of x equals square root of x as also f of x equals x to the power of 1/2 or 0.5. Okay, so both of these things mean the same thing. What are the properties? Well, the properties are that it has the same shape as half a parabola, but not going up, opening up or down. It's opening sideways. It has a minimum value for x and y, which is 0. So that's the lowest x and y can take, because you can't find a value on this parabola where the x value is lower than 0, or even the y value is lower than 0. And it's only in the first quadrant. So you only see this graph in the first quadrant. There's no part of it in 2, 3, or 4. So what is the domain and range of this function? Well, x, as you can see, the lowest it can go is 0. It can't take on any values lower than that. So x is a real number for all the real numbers from 0 and over, but it's always going to be either equal to 0 or greater than it. Similarly, the range also, y can be any real number, but y is also greater than or equal to 0 for the square root function, parent function. The next function we're going to look at is the reciprocal function, or f of x equals 1 over x. It looks like this. So this is an example of a function that has asymptotes in it. Okay, so it's f of x equals 1 over x. As you can see, it is when x is close to 0, the y value increases. So if you look at it right now, as you're going from here to here, x value is increasing, and as the x value is increasing, the y value is decreasing. Whereas if you go the other way around, when you get closer and closer to 0, as x gets very close to 0, the y value gets very high. So it's kind of an opposite behavior. When x increases, y value decreases and approaches 0. And when x approaches 0, the y value keeps increasing, but it never meets those axes. So this graph will never touch the x-axis, but always approaches it. And up here also it will approach the y-axis, but never touch it. Okay. It has a second half also in the third quadrant, where when x gets very close to 0 from this side, the y value is decreasing, and when x gets increasing here, the y value also is decreasing. All right, so the properties, we saw one property. Another property is when x is far from 0, the y value decreases. I just talked about it. The function has no value at x equals 0, y equals 0. So at this particular point here, there is no value. This graph will never touch the x-axis or the y-axis, so it doesn't have a value at these 2 points. Okay, so what is the domain and range of this function? Well, x can be any real number, but it will not be equal to 0, right? It can never be 0. And the range, again, y can be any real number, but it will never take on a value of 0. I think that there is also one more property, I may have missed it, which is that the graph is only in quadrants 1 and 3. Okay, the next function we are looking at is the parent function of the absolute value function, f of x equals absolute value of x. It has a distinct shape here. It looks like a V-shaped graph. So the properties are that you see two straight half lines that start at the origin and go up. So, and then it also has a vertex, which is right here at the origin, 0, 0. And the y value is a minimum. It's over here in this particular case, it's the lowest y can go is 0. It can't go any lower than that. So what is the domain and range? Well, for x, it can be any real number on the number line, no constraints. But for y can be any real number, but it can never go lower than 0. So it's always going to be greater than or equal to 0. So that is the range. So your homework for this section is on page 28 in your textbook, questions 1 to 3.